Okay. All right, so this first one, well, we have 3 unknown sides, no angles, so that's Pythagoras' theorem. So make sure to use Pythagoras' theorem for that one. Remember, this is the shorter side. Second question, all right, so they're looking for the area of the room, which means, so this is a mixture of trig and geometry, so that's plus geometry, the last unit, which your next exam is going to look like, a mixture of trig and geometry together. So this is an area split up into 2 areas, triangle and square. Should be no problem to you guys. Question 3 then, it's asked you on the diagram, draw a chord. So a chord is a, well, perhaps you do know, but a chord is a line. So you'll have to just do a quick sketch of this. A chord is a line that goes from one side of the circle to the other, but not through the center. Explain why ABC is 90 degrees. So that's one of your reasons, one of your circle theorems, one of the 4. So go to your notes to check that out. Question 4 is the only, well, it's a newish revision. Okay, so it's giving you a scale. Now for this, what I'd like you to do, because I presume you're not printing this out, you can just hold up a ruler to your screen and you're measuring the distance from A to B, and then 1 centimeter is 20 kilometers. So I'll just hold up a ruler to your screen. Okay. Measure the bearing from buoy A to buoy B. So this is bearings. I don't know if you remember this from last year, and that's the main reason I wanted to go through this. So bearings, remember, straight north would be a bearing of 0. All right, and then every other bearing is based off that. So if we have a bearing here, we look at this angle and we just say 135 perhaps is my bearing. If it's less than 90 degrees, you put a 0 in front of the bearing. So it's a 3-digit bearing. Okay, so B and A on my diagram here, it looks like, so B is here, A is somewhere here. It looks like it's going to be around, it's going to be more than 180 and less than 270 degrees. And this is why you will need a protractor when you come to this exam, which will be after the winter break, but you will need a protractor for the exam, and you will need a ruler for the exam. Okay, so it's just about measuring that angle around to there. So it's from here to there. So use your protractor, put it up again. It's going to be 180 plus this little bit. Part 3 then, the buoy is 120 kilometers, buoy C is 120 kilometers from buoy B on a bearing of 300. So this requires a combination of knowing trigonometric ratios and be able to draw bearings. So C, so if I use buoy B, and I'll go through this in greater detail tomorrow, but give it a go today. So 360 degrees would be a full circle around. So that's B here. And this is north. Sorry, this is B. And this is north. So 300 degrees is going to be, well, it's going to be 60 degrees off. So that's 60 degrees off 360 degrees, because 300 degrees going this way. So remember, bearings always go north and then clockwise. Start north and then go clockwise. So that's 60 degrees. And C is off here somewhere, 120 kilometers away. Okay. So that's how you would do that. Now I've done that here. You're going to have to draw a sketch of that yourself. Mark the position of buoy C. So try and replicate that. How did I do it? Try and replicate it without perhaps watching this video back. Question 5 then. So this is back to circle theorem, so I'm not going to go too much into this. Angle DEF, so DEF, so that's this one here in the corner, this one. And then you'll have to use trig ratios for the first time here. EF is 12 centimeters, so E to F, that's 12, so that's that hypotenuse of the right angle triangle is 12, and then you need to find DF. So you'd have to use either sine, cos, or tan for part 2. Question 6 then. The diagram shows a right angle triangle. So this is sine, cos, or tan as well. Label the angles, remember. So this is the hypotenuse. This is the adjacent because it's alongside. And then follow the system that was done earlier on in class. Next question, so we're on to question 7. Once again, so this is sine. No, this is not sine or cos or tan. This is just the 3 angles of a triangle add up to 180. So that should be easy to do. Part B, the diagram shows another right angle triangle. Work out the area. So area of a triangle, half the base and perpendicular height multiplied. Calculate the perimeter. You're going to need to use Pythagoras' theorem to find that extra side. It's a hypotenuse. You don't have any angles, so it's Pythagoras' theorem for B part 2. Question 8 then. So this is your theorem question. I'm not going to help too much with that. We just need a name for what that line is, like that. What's that called when it does that? And draw a radius. So I presume you can draw a radius. I think that was the previous exam question that you got last term. So A and B are points in circumference. Write down the name for AB. So that's another gimme question, a line that goes through the center like that. So question 8 and 9, particularly simple. Question 10 then, another right angle triangle question. This time we've got 2 sides and an angle, so that's going to be sine, cos, or tan. So label your sides and off you go. And question 11 is the final question, is another bearings question. So this time you have to measure the bearings of town B. So once again, if you don't have a protractor yet, just estimate. So starting from A, where is B? What angle does that make? Based off, remember, true north is a bearing of 0. Okay, and then once again, find the actual distance. So you're going to have to measure the distance between A and B, and then use the scale of 1 centimeters to 5 kilometers using, so you're going to have to measure it up against the screen using a ruler, or if you print it out, you can just measure it. Okay, so hopefully there's no questions, any of that. All of this is homework. There's 11 questions, but I don't think they're that difficult and probably not too time consuming. So you'll find that as a